Boom. Okay. So today, again, solving equations. We start off by solving radical equations. So here we end up with the cube root of 2x minus 4 minus 2 equal to 0. Okay. So our goal is to solve for x and get it out of that radical. So the first thing we're going to do is isolate the radical, and we're going to add that 2 to the right side. So that'll isolate this for us. So we get the cube root of 2x minus 4 equal to 2. And then we need to get rid of that radical. So to get rid of that radical, what power could I raise both sides to?
Third.
Good. I'll raise both sides to the third power because the cube root and the third power will cancel. And that'll leave me with 2x minus 4 equal to 2 cubed, which I think is 8. Move the 4 over. We get 2x equals 12. And x is equal, what?
To 3.
6.
It's 3.
Half of 12 is 6.
Right?
Hey,
What's 12 divided by 2?
You divided by 2x. Yeah, it's 6.
There you go. Good, good. All right. And there we go. So we get x is 6. And of course, you could check your work to see by plugging your answer to see if it works out. Since this is a single answer, it should work out. And in the other examples we're going to get into, we'll get probably 2 answers, and we're going to definitely want to check to see if those work. So it's always important to check your work to see if you have the right answer. But here we get x equals 6. Any questions on that? Everybody good?
For the homework, are we supposed to print it out?
Oh, for these notes or the homework?
Like, well, I guess the homework.
So if you're doing homework on Mymathlab, you don't have to print anything out. So you do homework on Mymathlab, and you should be writing on your own separate sheet of paper. So you'll submit homework in Mymathlab, and whatever you write down for shown work is what you'll upload to Canvas.
Okay, thank you.
Yeah. These are your notes.
Is there a way to print out the questions from Mymathlab? So I don't have to be on the computer to...
There should be. I guess we can explore that option in a moment.
I tried looking, and I can print out each individual one as they go through them, but I can't print them all out.
I was going to say that exact thing. I was looking for a way to print the whole assignment out at once.
Oh. If not, if it does it question by question, then that sucks. But
yeah,
that
sucks.
if you really want to print out, I can get you one, but that's not going to match the work that you submit on Mymathlab.
Yeah, I know when I was looking into it, basically it said that you can only print out work you've already completed anyway. Because like the problems that have multiple parts, it won't print out the parts you haven't accessed yet. So like you can't pre-print the exercise.
That's weird. Because on all the assignments I have, they can print assignment is checked off, but I guess that means they can only print out questions they completed, right?
I guess so, but also you tried to make me a TA and it just didn't do anything. So
yeah, it doesn't work. Yeah. Ooh, yeah. Well, I mean, because you guys just don't like staring at the screen, or you don't.
I work on the computer all day long, and I just don't want to. I want to do it on paper and then later on submit it.
Yeah. Ooh. So yeah, I don't know if that's gonna work out, but I'll definitely look more into it. But yeah, I mean, printing is on, but I guess that's the only way you can print. But yeah, I'll definitely check it out more.
Cool.
All right. Okay. 2. So here we're solving for t. Same situation as above. We have to get t out of the radical. So this is a square root. So in order to get rid of that square root, what would you raise both sides by?
2.
2. Good. And then here, you'll get 2t minus 1. 1 squared is still 1. Add that 1 over. 2t equals 2. Divide by 2, and we're going to get that t is equal to 1. All right, not bad. All right, everybody good?
Yep, I'm
Okay.
good.
Okay, let's keep going. This is just the warm up, right? Warming up. All right. 3. Again, same situation as the last one. You have the square root of x minus 1 equal to x minus 7. We need to get rid of that radical. So what are we going to do What are we going to do to both sides?
Multiply by 2.
Not multiply, but
What is it called?
we could say raise it by 2.
Yes, raise it by 2. My fault.
Or we could say square both sides. Okay. So here we have to get rid of that radical. It's isolated. We square both sides, and we get left with x minus 1 on the left side. But now since we squared the right side, how many copies of x minus 7 do I have?
2.
2. So we'll write that as x minus 7 times x minus 7. And now we have our work cut out for us because now we have to FOIL the right side. Oh yeah, and these notes you don't have to print out. If you're writing on your own sheet of paper, that's fine. Remember, these are notes and these are for you guys to keep and reference. You never turn these in. All right. FOIL this out. You should get x squared minus 14x plus 49. And then move x minus 1, move these over to the right side. So I get 0 on the left side. So if I move those over, I should get x squared minus 15x plus 50. Everybody good?
Yes, sir.
Then we have a quadratic equation. And how can we solve for x on this quadratic equation? What method could we use? Well, what's the easiest way to solve a quadratic? Starts with an F. It's your favorite F word.
It's
Factor.
Factoring.
The
Factor.
quadratic equation.
Factor. Everybody's favorite F word. So we factor. And there's minus and plus. So that means it's going to be x minus a number, x minus a number. And what are 2 factors of 50 that can make 15?
10 and 5.
Yeah, 10 and 5. Which means what are my 2 answers?
10 and 5.
There you go. 10 and 5. We just said it. X equals 10, x equals 5. But since we have 2 answers, we have to check. Who's going to work? Who's not going to work? So let's go with 10 first. We'll plug it into the original one. You get the square root of 10 minus 1 equal to 10 minus 7. This gives me the square root of 9 equal to 3. Is that a true statement already?
Yes.
Yes.
Yes, so that checks out. This means 10 is good. Now let's try 5. Square root of 5 minus 1 equal to 5 minus 7. This will give you the square root of 4 equal to negative 2. Does the square root of 4 equal negative 2? Should, I guess another way to put it is that, should a negative number ever come out of a square root? No. So we know that this would be 2 equals negative 2, which is not true, which means that x equals 5 does not work. And we call this our extraneous solution. Mainly because this solution was being real extra. Okay, we don't need that. All right, so if you get more than one answer, you always want to check your work, see if it works. There you go. Okay.
Quick question
Go ahead.
on that. Why? Well, okay, I think I already figured it out, but if we have 2 answers, why do we have to, never mind, I already answered my own question by thinking about it.
You keep answering your questions. Were you gonna say, why do we have to check it, or?
Oh, I was gonna say, why can't we automatically assume that the 2 answers are correct if it's squared, but then you kind of just already proved that.
Good, because we plug it into the original to see if it checks out, right? If you plug it into the square, I think they would all work out. Because if you square a negative number, it's going to be positive, right? But that'll just be lying to ourselves. But that's a good question. Good. All right. Any other questions on this one? Dun, dun, dun. Cool. All right. Let's keep moving. 4 and then 4. Perfect. Okay. Awesome. So number 4, once again, we need to solve for x. We need to get rid of those radicals. So what do you think our first step is? Wrong answers only.
Oh, square the whole thing.
Square the whole thing. All right, Carl, let's see. If we square both sides, is that the way to go? You guys are just believers at this point, right? You're like, yeah, just go ahead and square it. It's good to go. Okay, I'm going to tell you right now, this is not a good idea because you create a monster. So if you square this, it doesn't get rid of the square roots. It creates a duplicate copy. And you don't want that. Because don't write this down, but look, if you square this left side, you get the square root of 2x plus 3 minus x plus 2 times the square root of 2x plus 3 minus the square root of x plus 2. And now you're going to have to FOIL all of that out. That is just nasty, right? That's no good. So we have to think of a better way. And it's kind of what we've been doing the whole time. I've mentioned it a couple times, and I say isolate a radical. Get a radical by itself. So that means let's go ahead and keep this one on the left side. And let's go ahead and add this radical to the right side. That's what we're going to do. So I'll get the square root of 2x plus 3 equal to 2 plus the square root of x plus 2. So we move that to the right side. This is going to make our work a lot easier. And then we are going to square both sides like we've been doing. Now this is still a monster, but it's not a terrible monster like the last one. So the left side, the roots will cancel, and we'll get 2x plus 3 equal to, and now, since we're squaring the right side, it creates a duplicate.
Sir, what about the negative that's at the center? Shouldn't that be a -1? at the original problem, or did we just discount that and not pay attention to that?
This one?
Yes.
So how did we get it to the right side? So that's the negative square root of x plus 2. So to get it to the right side, we have to what?
Add it.
Add it to it.
Add it. And therefore it becomes positive.
Okay. All right. That makes sense.
Good? Mm-hmm. Good. All right. Awesome. No, good question. Very good question. Okay. So now we square both sides. We still have a lot of cleanup on the right side to do. So the left side's perfectly fine. And now we must FOIL everything over here. So you'll get 4 plus 2 square root of x plus 2 plus 2 square root of x plus 2 plus, all right, good question for you. What is the square root of x plus 2 times the square root of x plus 2? What do you think is going to happen there?
What is the what?
What is the square root of x plus 2 times the square root of x plus 2?
Oh, x plus 2.
That's it, x plus 2. Since they have the same term inside the radical, and since they are both square roots, the square root of x plus 2 times the square root of x plus 2, they are going to cancel. And there you go. You can even put in parentheses for good measure. It's a good habit to do that. We don't need them on this one, but in case there was a negative out front, it would be ideal to put parentheses around it. Okay. And now let's go ahead and combine like terms on the right side. Left side is still good. So I have 4 and I have 2. We get 6. I have 2 square root of x plus 2 plus 2 square root of x plus 2. What does that give me?
4 square root of x plus 2.
4 square root of x plus 2. And this x is all that's left over. Okay. Oh, we still got a mess, right? Now we have to get rid of this radical, which means we need to isolate this term on the right side, which means we're going to take x and we're going to take 6 and we're going to move them both to the left side. So subtract an x and subtract a 6. And if I subtract x, that'll give me x. If I subtract a 6, I'll get -3, and I'll be left with 4 square root of x plus 2 on the right side. So move the 6 over, move the x over. Here's what we're left with. And now we want to get rid of the radical. The 4 is perfectly fine attached to it. How do we get rid of that radical again? What do we do to both sides?
Divide both sides by 4.
You can, but you're going to make a mess. Leave the 4 there. It's okay. And the reason I'm saying it's okay is because this 4 is attached to the radical by multiplication. Earlier, that 2 was attached to the radical by addition, which created a monster for us. Now, if this 4 is attached by multiplication, it's no longer a monster for us. So we can say square both sides. And watch the magic. All right, so we're gonna square both sides. Now the left side, x minus 3 squared, means we have 2. X minus 3 times x minus 3 equal to, all right. Now, here, it's gonna be great. What is 4 squared?
2.
16.
Squared, not
What?
square rooted, right?
Oh,
16. You're good. And then what happens when you square the square root of x plus 2? What does that become?
X plus 2.
X plus 2. And make sure to put it in parentheses. Now look at that. Do we have any more radicals? No. Now, all we have to do is a lot more algebra and solve for x. We're almost there. FOIL the left side. You'll get x squared minus 6x plus 9. Distribute the right side. 16x plus 32. Move everything to the left. So take all of these, move them to the left by subtracting. And we should get x squared minus 22x minus 23 equal to 0. And now, once again, we have a quadratic equation, which we hope can be factored, which it is. This is minus minus, so it'll be x plus a number, x minus a number equal to 0. What are the only factors of 23 that can make 22?
1 and 23.
1 and 23. 1 and 23. Good. Now, solve for x, and what are my answers?
-1 and 23.
-1 and 23. Which one works? After all that, you still got to check your work, right? So if you plug in -1, you'll get, what's that? -2 plus 3, you'll get 1 minus the square root of 1. So I think -1 is out. Trust me. -1 is out and 23 is going to work. All right. But again, don't be afraid to check it. I'm just saving time. Okay. Before moving on, any questions on that? Any of this look familiar from your last class?
Yes.
Yeah.
You're like, I remember this shortly.
I used to hate that check my work stuff.
You got to do it. It's worth it.
Uh,
Just see it as a process of you computing numbers faster, right? I just looked at it and I was like, hey, -1's not going to work. Just takes time, right?
yeah.
All right. Excellent. Let's keep going. Oops. Okay. Next is solving equations quadratic in form. So if you learned U substitution, great. If you didn't, then this is going to be something new. And also, you don't always have to do U substitution if you don't like it. But the reason we use a process called U substitution is because it takes a quadratic equation in form and actually puts it into a quadratic form. So it makes it easier to factor when you do it that way. So we'll show this by U substitution, and we'll show it by not U substitution. So here we want to factor x to the 4th plus x squared minus 12. And this is called quadratic in form, but it's not what we're used to because the leading power is to the 4th. Normally, the leading power is squared, and we're good with that. So U substitution will put it into a quadratic form, making it easier to look at. So the way to use U substitution is you will always substitute for the middle terms variable and power. So what I mean by that is if the leading term is x to the 4th, the middle term's x squared, this is what we're going to make U as. So U is going to be x squared. So let me just write that to the side. U is going to be x squared. Now, since we're making U substitution, we need to make a substitution for all the x's, which means we have to make a substitution for the leading term x to the 4th. So the only way to do that is to take our substitution that's here already and square both sides of this substitution. So I'll write it again. I'll say u equals x squared. And we're going to square both sides of this substitution, meaning we now get u squared equals x to the fourth. And we wanted to make a substitution for x to the fourth, which means since we have completed this substitution, we can now state that x to the fourth is now going to be covered by u squared. Okay. Now let's put the whole substitution together. And our new quadratic equation in terms of u substitution is going to be u squared plus u minus 12 equal to 0. And now what we are seeing is that when we apply u substitution, it puts the equation in quadratic form. And when I say quadratic form, the leading term is now squared instead of to the fourth. Everybody good with that? Yeah. And since it's quadratic in form, it now looks more factorable. So this is going to factor to u plus a number, u minus a number equal to 0. And what are the only factors of 12 that can make a positive 1?
3 and 4.
3 and 4. Which one's positive? Which one's negative?
3 is negative.
Good. And 4 is
Positive.
positive. Good. Good. And now solve for u, and you get u equals negative 4 and u equals 3. But now, since we made a substitution, what did we substitute in place of u? Or what did u substitute
X
for?
Power of 2.
Good. So the u has to become x squared again. Which means let's use different color. This becomes x squared equal to negative 4. This becomes x squared equals 3. And we still have our work cut out for us because now we have to solve for x. So to solve for x, what do we do to both sides of this?
Take the square root.
Good. Take the square root. So we say square root, square root, square root, square root. And over here, what happens when you square root a negative?
Becomes a positive.
When you square root a negative, what type of numbers come out?
Imaginary.
Imaginary, right? So this is going to be plus or minus 2 what?
I.
Good. And over here is just going to be x equals plus or minus. Can you take the actual square root of 3 evenly?
No.
No. So it's just going to remain the square root of 3. Now, I don't know if Mymathlab is going to take imaginaries right now. So if anything, your only answer here is going to be plus or minus the square root of 3. Okay. And like I said, I'll show you the other way where you don't have to use u substitution. We can automatically factor this guy already. So x to the fourth plus x squared minus 12. Well, hey, that just factors to x squared plus 4, x squared minus 3. That's it. No u substitution needed. And then you solve for x. You get x, I'll put that equal to 0. You get x squared equals negative 4, x squared equals 3, and we are right back here. So use u substitution if you want, or see if you can factor it in another way.
Will there be any situations when using U substitution is an absolute must, or is it there just because it is?
It's there just to be helpful. You don't have to use it if you don't want to.
Okay.
So in some cases, it's pretty useful, so you avoid lots and lots of algebra. But other cases, you can just decide whether you want to use it or not.
It is something to get used to your brain saying because it will come back in calculus.
I see. Okay.
Okay.
It helps to sort of get your brain used to understanding that all of these things are just representing something else, and we can do all kinds of weird math tricks to make them represent something else more than that to try to figure out solutions to things.
Mm-hmm. All right. Sweet. Carl, I'm going to tag you in. You ready?
Cool. Yeah, let me get the link to yours and I'll jump on there and do it on your notes.
All right, sweet.
Hopefully it'll let me actually do it live.
It should. It worked last semester when we did it, right?
Yeah, but I'm not sure if it okay, here we go. Yeah, it's a and we're in 1.4, right?
Yep.
Oh geez. Okay. Don't explode on me. Oh man. Hopefully this is okay. All right. Let's see if this will work. Okay. Yes. Sure. All right.
There you go. Cool.
So nope. I need a pin. Yes. We'll do a pin. Okay. So let's see. Does it work? Oh, sweet. I always rewrite the problem. It can waste time, but it's always something that sort of helps me make fewer mistakes to always rewrite the problem. So what I am noticing here, notice x squared minus 1 squared is just x squared minus 1 squared. Isn't that convenient? So we will say let u equal x squared minus 1. So then we get u squared plus u minus 12 equals 0. And what you'll notice from above, right? Roll back up here. We just did this problem. So we can go through all this work again to either factor it down the same way. So you could do u plus 4, u minus 3 equals 0. So then you get u equals 4. Just kidding. U equals -4 or 3. And then of course you plug that in and then you would get x is equal to plus or minus 2i, or x is equal to plus or minus the square root of 3. Again,
wait, because you're missing out on the 1.
Oh, the -1. Yeah. What am I doing? Okay. Let me...
Terrible math. All right. Before he keeps going, though, does everybody understand how we did a substitution?
Yes, sir.
For the x squared minus 1? Everybody good with that?
Something to help you. I guess a thought I had around this time in college algebra that really started to save my life was that something like x squared plus 3x minus 4 or something like that. I don't even know if this is factorable. Something like this. This is just a number. This whole thing is just a number, right? Because if we plugged in something for x, right, say we let x equal 1, then you would get 1 squared plus 3 times 1 minus 4. So that's 1 plus 3 minus 4, and that's 0. right? So this whole thing just represents one number. So whatever you can do to one number, you can do to any kind of polynomial, anything that has any number really of variables and other things going on in it, you know. So it kind of helps to start thinking about these, especially as you go higher in math, as these whole quantities, you'll hear me call these quantities sometimes, it's just one number. All right, so to do my math intelligently, then I have to say then that, sorry, since we let u equal x squared minus 1, we have to say u equals x squared minus 1, and we'll start with -4. So we get -4 equals x squared minus 1. Add the 1 to both sides. -3 equals x squared. Take the square root on both sides, and you will get... Is there like a smaller line here? Here we go. Square root on both sides. And you will get plus or minus 3i equals x. And then if we do it on the other side, we have u is equal to, again, x squared minus 1. 3 equals x squared minus 1. You will add the 1 over there, so that is 4 equals x squared. We will take the square root on both sides, and that gives us plus or minus 2 equals x. And this is why you shouldn't rush things, because you'll avoid simple mistakes like I did, like forgetting we changed problems completely.
Somebody catches other simple mistake.
What I do wrong?
On your 3.
What about it?
Think about it. You took the I out, but shouldn't it remain I square root 3 plus or minus?
Oh yeah. Duh. We don't know.
Square root there.
We don't know what it is.
You're good.
So it's plus or minus I square root 3.
There you go.
Yeah. There we go. Because square root of 3 is irrational. All right. So, and then, you know, you can do a check since you have something you notice here, right? Since we started with squared and then we squared it again at some point, we actually have 4 answers, right? So we'll just check just the real numbers, right? The 2 is the real number. We'll check just that real quick. So let's do it. We got what would it be? It's 2. Well, if we do positive 2 first, then that's 2 squared minus 1 squared plus 2 squared minus 1 minus 12 equals 0. So what do we get? We get, well, this will be 4 minus 1 squared plus, this is 4 minus 1 minus 12 equals 0. So that's 3 squared plus 3 minus 12 equals 0. 9 plus 3 minus 12 does in fact equal 0, because this is 9 plus 3 is 12, minus 12 is 0. If you check the -2 in this, do you see why it'll automatically work out? Anybody? But you don't have to recomplete the work for the negative.
Squared.
Right? Because it's squared. So whenever you square a number, you'll get positive. So we'll get these same 2 positive numbers at the end. So because of this, we automatically know that our answer is -2 and 2.
Yay. Okay. Any questions on that one? So I would say this is an instance where U substitution is actually helpful.
Almost necessary.
You can factor binomial means, it's just harder to look at. Mm-hmm. And then a third way of solving it is by foiling everything out and combining like terms. But why would you do that when U substitution makes your life easy?
And more than likely, when you foiled everything out, you would get a x to the 4th in there anyway. You may have to U sub it or do a more complex method of factoring to get rid of that x to the 4th anyway. So U sub's your friend. Learn to love it.
Excellent. All right. Everybody good on that? They're like, what just happened?
I go kind of fast. I'm sorry. I still got to learn to slow down. I'm like still in the mentality of working in the tutoring lab where you have 5 minutes to work with a student and try to help them do like all their homework. So,
okay. We'll finish on these last two and we can touch on the other ones next time. But yeah, we'll do 3 and 4. And again, we can do use substitution. So here for number 3, I have x plus 2 squared of x minus 3 equal to 0. Now, if you look at that, that doesn't look like you can factor it by normal means, which again, use substitution comes in handy. So once again, if I go with use substitution, I'm going to let u equal the smallest power of x. So who's smaller, x or the square root of x?
Square root of x.
Square root of x, good. Because honestly, what is the power on the square root of x?
It's -2, right?
Nothing negative. So if you went from radical to exponent, what would the exponent be on x?
Oh,
radical?
Squared.
Get in there.
1/2.
There you go. 1/2. Therefore, this is why this is smaller than that, right? So just some stuff, right? Nothing crazy. So we're going to say let u equal the square root of x. So once again, I'll just write it out. Here's our substitution. U equal to square root of x. And now we need to cover the leading term of x. And just like we did on the last ones, if you square them, you're going to end up with u squared equals, and what is the square root of x squared?
X.
Just x, which covers my leading term, right? So that becomes u squared. Now, let's write it out. We get u squared plus 2u minus 3 equal to 0. Okay, now factor it. Yes, all of these are factorable. That's how I made these notes. So you'll have u plus a number, u minus a number equal to 0. And hey, what are the only factors of 3 that can make 2?
1 and 3.
1 and 3. Who's positive?
The 3.
3 and the 1's negative, right?
Yes.
Perfect. Okay, now solve for u. U equals -3, u equals 1, and we must remember that we made a substitution. So what did we substitute in place of u?
Square root of x.
Square root of x. Okay, and now we want to solve for x, but it's trapped under that radical. So what are you going to do to both sides?
Square it.
Square it. Good. I'm only going to do this one, though. There's a reason for this. You have to think again about properties of square roots. If I take the square root of any number, am I ever going to get a negative result?
You shouldn't, no.
Never, right? Never. So I'm not even going to bother with this answer because nothing negative should ever come out of a square root. So this is going to be our extraneous. Even if you did square it, you would get 9 and it wouldn't check out. So still, it's no good. Good on that? All right.
Yes.
All right. Let's see. Yeah. Okay. All right. Last one for the night. x to the 3/4 minus 9x to the 1/4 equal to 0. That's a definite u substitution if you want it, right? So what part will we let u substitute for?
X to the quarter.
Good. X to the quarter. So here, we're going to let u equal x to the 1/4. Because 1/4 is smaller than 3/4, right? And now we need to make a substitution for the leading term. Now, normally, what would we do to both sides? What have we been doing all day?
Squaring.
Squaring it, right? But is this going to work out in this situation?
No.
No, I'm going to get x to the, and what's 1/4 times 2? Power to a power you multiply.
It's 2?
So I'll get x to the
half?
2 over 4, which gives me x to the half. Does this cover my leading term?
No.
No. So we have to go back to the drawing board. And instead of squaring it, what else could we do here? How could I get that 3 up there?
Do we divide it?
No dividing. We're still raising. There's nothing to divide by here. We would just make more of a mess. Well, if squaring it put a 2 up there, how could you put a 3 up there?
By cubing it? I don't know.
That's it. Yeah. Cube both sides. We're not doing anything wrong here. Cube both sides. If I cube both sides, I get u cubed is equal to, and what's 1/4 raised to the 3rd? Remember, power to a power is multiplication. So what's 1/4 times 3?
3/4.
That's it. 3/4. And does that cover our leading term up there?
Yes, it does.
Yes. Oh my goodness. Now let's put it in. Let's say u cubed minus 9u equals 0. And now, what could you factor out?
U.
You. Me? All right. And if you factor u out, what are you left with?
U squared minus 9.
U squared minus 9. And u squared minus 9 is a what? It's a difference of
Squares.
squares. So what is u squared minus 9 factored to?
Something plus 3, something minus 3.
There you go. In this case, it's u. It's always been u. Okay. So now, set all of these equal to 0. And we're going to get u equals 0, u equals -3, and u equals 3. But what was u?
Cubed.
No, u was
X to the 4th.
x to the 4th.
Yeah.
X to the 1/4 equals 0. X to the 1/4 equals -3. And x to the 1/4 equals 3. Okay, well, now, how do I get rid of that 1/4?
To the 4th root?
Not the 4th root. It's already a 4th root. So if I asked you rewrite, if I asked you rewrite that as a radical, what would you write? What's the power of the root?
It's the 4th power, right?
You would get the 4th root of x equals 0. Right? And how would you get rid of that 4th root? What would you raise both sides by?
4.
4. Good. So I guess let's just do rewrites on all of these. Before I raise everything to the fourth power, which one am I going to ignore?
The negative.
The negative, because once again, this is a fourth root. This is a even root. Should anything negative come out of an even root? No. So that's gone. And now we can say, raise all of these to the fourth. And lucky for us, the first solution is what?
X equals 0.
And then what's the next solution? What is
X
3
equals
to the
27? Or no, I didn't go high enough.
More.
81.
81. And there we go, guys. 0 definitely checks out, and 81 definitely checks out.
Oh, you don't want to do the work to check them?
Oh, fine. We got time, right? Fine, Carl.
Just do
He's
81.
down bad.
I'll do.
Just do 81.
I'll do 0.
0 is so obvious, though. Just do 81.
Hey, you don't know what 0 to the 3/4 is, okay?
You want to bet?
You haven't. You don't know my life. I'm gonna make them do it anyways. All right, 81 to the 3/4, y'all. What's another way to rewrite that?
The fourth root of 81 cubed.
Hey, it wasn't you were supposed to answer, okay? The fourth root of 81 cubed minus 9, and what's 81 to the 1/4? Rewrite that one.
The fourth root of 81.
There you go. Bringing back all the skills you learned, right? And now, what is the fourth root of 81?
3.
3. And what's 3 cubed?
27.
And what's 9 times 3?
27.
And 27 minus 27, is that 0?
Mm-hmm.
Yes.
Yes. Or if I just add that 27 over, just to blow minds. Hey, it works, right? Either way it works. 0 equals 0, and we check out. Done. Thanks, Carl.
Yeah.
Keep me on my toes. Let me check my work.
I just figured that would be a good one for him to see, because that little, the power trick to make that, that 381 to the 3/4 power is going to be, it's useful to see stuff like that.
For sure.
You guys know why that works? Why you can just do that?
Do what?
Why you can rewrite the 3/4 power as the fourth root of 81 cubed?
They should know their radical properties, right?
You hope, but who knows? We have review at the beginning of this class for a reason.
Right? How about this? We can review for 1 second because we're a minute over. All right, y'all, real fast. What are 2 ways to rewrite x to the m over n?
The nth root of x
to the nth
power.
And one more. Or maybe I wrote the wrong one and you were thinking of this one.
You can also leave the m on the x.
Like this one.
Mm-hmm.
There you go. Remember your radical properties, guys.
You could also write it as x equals n, x raised to the n, and then that whole thing raised, or to the 1 over n.
That's right.
X to the 1 over n.
Oh, yeah, the other way. M 1 over n. There you go.
Yeah.
All right. So many possibilities.
remember this stuff. It's important. You're going to get to calculus. If you can't remember this, you get your ass kicked.
Dang, the only one I remembered was the first one.
Don't even try to take differential equations without this. All you want to be engineers and computer scientists, don't even try it.
Don't even try. Don't scare them. Don't worry. We're in college algebra, guys. We'll get out of here. Okay. Class is over. Any other questions before we head out?
A couple people want to know about attendance.